Today's lesson is how to interpret a series and parallel circuit in a combined question. So figure 8.1 shows a 12-volt battery connected to a resistor and a component X in series. Identify the component X. So X is a diode. What a diode does is it allows current to flow in one direction only, which is indicated by the direction of the triangle, which you can see in this diagram. And the way that it works is a diode doesn't become operational until there is a certain voltage passing through it. So if we look at the formula V equals IR, when the voltage reaches a certain point, then it becomes activated, if you like, and the resistance of the device basically drops to zero. One of the sketch graphs you need to know is the one where you have current against voltage. The diode one kind of looks like this, where the current is zero. You can see the blue line there, and then suddenly it just shoots up almost vertically. So that is when the voltage hits a certain value, and then the diode operates and the current approaches an infinite value, which means the resistance decreases to basically zero. Right, so now that I've said that, the potential difference across the form resistor is 11.3 volts. Calculate the potential difference across component X. So we have a series setup. I said in my last video that in a series circuit, the voltage is shared amongst devices. So if 11.3 volts is going to the 4 ohm resistor, that means 0.7 volts is going to the diode. Part 2, the current in the 4 ohm resistor. So I equals V over R equals 2.83 amps, 4 ohm resistor. Now let's look at the modified circuit, and it's been changed into a parallel setup. So you can see in this case the 8 ohm resistor is now branching across the 4 ohm resistor and the diode, which is there. So we can ignore the internal resistance of the diode. So basically you can think of it as zero. Part 1, calculate the current across the 8 ohm resistor. So we know that in parallel each branch gets the same voltage. So I equals V over R, so 1.5A. Number 2, the current in the battery. Before I can work out the current in the battery, I will need to know what the current is across the other branch, the 4 ohm resistor. Now remember what I just said. We're going to treat the resistance of the diode as zero. I can just go ahead and work out what the current will be along the branch with the 4 ohm resistor. This time it's going to be 12 divided by 4 gives us 3 amps. So therefore, we know the resistance along the 4 ohm resistor branch, it's 3. We know the resistance along the other branch, which is 1.5. In parallel, current always splits across the branches and then adds back together. So the current is 4.5 amps. Finally, the battery is now reversed. State the current in the battery. So what happens is you have exactly the same current, but it'll just be negative 4.5 amps. I will be doing another one of these combined circuits questions, so please go and check that video out now.